Reflection is a process by which a traveling object strikes a surface and then bounces off. The traveling object can be a baseball, or it can be a tiny particle of light. Before we get into the rules of reflection, it's important to be familiar with a few key terms. The first one is the incident ray. That's the ray that's traveling before it hits the object. Once the object bounces off the surface and is traveling in a new direction, that's called the reflected ray. There's also an imaginary line that we call the normal, and that is the line we draw that is perpendicular or at a right angle to the surface the object is bouncing off of. There's also something called the angle of incidence. That's the angle between the incident ray and the normal line. The angle of reflection, on the other hand, is the angle between the reflected ray and the normal line. One of the rules for reflection states that the angle of incidence is equal to the angle of reflection. An interesting thing happens when a ray of light hits a curved surface. If you think about this individual yellow ray of light, when it strikes the mirror, that ray of light is only influenced by the tiny point on the mirror that the particle strikes. So other parts of the mirror that are curved, like these blue lines, don't influence that individual ray of light. In other words, that tiny ray of light is going to bounce off the mirror as if that tiny spot on the mirror were part of a larger, flat mirror. And if we imagine that red line to be part of a larger, flatter mirror, we could still draw our normal line, or a line that is perpendicular to that tiny point on the mirror. And now we have all of our parts. We have the ray of incident, we have the reflection ray, and we have our normal line. And even though my drawing isn't completely to scale, in reality the angle of incidence will still be equal to the angle of reflection. And knowing these rules, we can anticipate how a curved mirror would actually bend light. If a ray of light were to approach this mirror from the opposite side and hit the convex portion of the mirror, the same rules would apply. We draw a ray of incidence, and then we draw our perpendicular normal line, and then the angle of reflection is equal to the angle of incidence. So in this case, my purple ray of light would strike the back of the mirror and then bounce upward. Refraction is a bit different than reflection. In reflection, the particle of light bounced off a surface. In refraction, the particle of light travels through a new medium. And as we saw in the video for optics basics, a ray of light will bend as it enters into a new medium that is either faster or slower than where it was before. The index of refraction is a number that represents the ratio of the speed of light divided by the speed of light in the new medium. And the slower light moves in the medium, the more that medium can bend light. Snell's law is used to calculate how much the trajectory of a ray of light changes as it changes medium. Snell's law is that the index of refraction for a material times the sine for the original angle, or the incident angle, that's going to be equal to the index of refraction for the new medium times the sine of the new angle. In this situation here, the first n would be referring to the index of refraction for the air, which is always 1. The second index of refraction, the second n, will refer to the index of refraction for the glass of water. Incidentally, the index of refraction for water is roughly 1.3, which means that light travels 30% faster in air than it does in water. So we know light can bend as it travels from one medium to another. Sometimes it bends a little, sometimes it bends a lot. In fact, there's even a point where light can bend so much that the light waves don't actually exit the first medium. There are times where if the angle is just right, you can be underwater and look up at the surface of the water, and that surface will act like a mirror. That's because the angle is such that the light waves you see are not escaping the water but being bounced back towards your eyes. There is something called the critical angle, and that is the smallest angle you can have relative to the normal line that will cause internal reflection. And that angle is different for any two mediums. The equation for the critical angle is the sine of the angle is equal to n2 over n1. n1 refers to the index of refraction for the medium that the ray of light is originally traveling in. So in this case, n1 would refer to the index of refraction for water. In this case, n2 is referring to the index of refraction of the air above the water.